The next presenter now, XTPL. I'm very interested to hear this one because, of course, I'm interested in quantum dot color conversion, which it sounds like they do a little bit of printing in that area. So we are going to speak with Lukasz today, and he's going to tell us about sub-micron digital printing for micro-LED, microbumps, and QD color conversion. So go ahead and take it away, Lukasz.
Okay, thank you for your kind introduction. Hello, everyone. My name is Lukasz Kosior, and today I will show you some examples and how XTPL technology can do a sub-micron printing for micro LED, micro bumps, and quantum dot color conversion. So I will start with a short introduction of our company. We are based here in Wrocław, Poland since 2015. Today, our team is growing very fast. We have over 40 experts in the fields like chemistry, mechatronics, software engineering, and more. We, as a young company, we are listed on Warsaw Stock Exchange, also on German Stock Exchange. And of course, we are still applying new patent applications to secure this unique technology. Today at XTPL, we have three main business lines. First is data printing system, which is standalone equipment for R&D and prototyping with all capabilities of the XTPL technology. Second is a strong collaboration with industry partners on integrating XTPL ultra-precise deposition technology in the manufacturing equipment. And our last business line are highly concentrated metallic nanoparticle-based inks and pastes. So I will start with a short introduction what actually XTPL technology is. So it's a nano-dispensing approach which combines unique process design, printing head construction, and ink stability to achieve even sub-micron resolution with no electric field required on almost any kind of substrate. What's also important, it allows to print high viscous materials, even up to 1 million centipas, which comes with high density of solid particles inside the material in a full resolution range. So the combination of printing parameters, printing head construction and materials opens some unique for additive technologies features that you can only achieve with our approach. With ultra precise deposition technology, it's possible to print high aspect ratio conductive traces down to 1 by 1 micrometer line space, even on complex three-dimensional topographies like 90-degree sidewalls. Unique features portfolio also include printing high resolution and high aspect ratio microbumps down to 1 micrometer in diameter and precise filling of microcavity structures in a single femtoliter scale. And you might ask which of these features are applicable for flat panel display, and the answer is actually all of them. And on the next slides, I will show you why. So, as promised, I will show you a couple of examples of where the technology I'm just presenting can be used for a flat panel display, especially thinking about this next generation high resolution displays. So the first example is printing array of source and drain TFT metal layer for fully printed flat panel display. And on the same SEM images, you can see the resolution achieved. Measured line width is 4 micrometers, and what's at least at the same level of importance for this application, repeatability of the geometric parameters and stability of the process over the time. One of the interesting applications that actually even today in the short term XTPL technology can be applied is repairing broken conductive traces. And during production, even single dust particle can make a defect in the display, which can be classified at the end as a killer defect. To repair it, only high resolution additive method can be used, and today is one of the main candidates to do this. On the image, you can see how challenging and complex TFT array in high resolution OLED display is.